All right, section 5.1 is a section on the rules for exponents. The screen that you see in front of you is the rules for exponents. This page was actually a cut and paste out of the review for chapter 5. At the end of chapter 5 in the textbook, there is a review, and this is a summary of the rules. It is so tiny it is difficult to see, so I'm going to go to a new page and write out the rules so that everybody in class can actually see them. We will use these rules as we go along. All right, the first rule is called the product rule. All right, the product rule says the following. Now, I'm not using the same letters that might be used in the textbook or that are on your blue sheet because these rules are on your blue sheet. I'm just going to use some letters I'm thinking about right now. The product rule says if you have a base and you raise it to a power and you multiply it by the same base to a power, so I have a raised to the x power times a raised to the y power, what you do is you keep the base a and you add the exponents. So that's a to the x plus y.
Do we have to have a plus sign?
No. Just in the rule, we would have to have the plus sign, but good as an example, if you had, let's say you had z to the third times z to the fourth. What does the rule say? To multiply, you're going to take z to the 3 plus 4, which is z to the 7th.
So would the first one have been x, y, a?
No, because if you had x, y, that would look like x times y. So I can't add an x to a y, so I leave that shown as a sum.
Okay.
But this one, I can add 3 and 4, so I do. Now, why does it work? Well, what does z to the third really mean? Doesn't it mean z times z times z? And z to the fourth is really z times z times z times z. And how many factors total of z do I have now? I have 7. So that's just trying to convince you that it makes sense as a rule. So when you multiply the same base, you add the exponents.
You always add, because see, just by looking at it like that, without you putting the plus over here,
Uh-huh.
I would have multiplied 3 times 4.
And you would have gotten 12, and now look at it logically, are there 12 factors of z? No. There is a situation where you multiply, and we will look at it. In fact, it comes next. So that's the product rule. When we go through the MyMathLab questions, I'll be using these different rules. The next rule is the power rule. And the power rule says if you have a to the x and you raise that to the y power, now you multiply. This will be a to the xy power. Yes. And you have just identified a visual clue. When you see parentheses and a power on the outside, you're probably dealing with the power rule, and you multiply the two exponents. Let's see if that makes a little sense. If I have a to the second, and I raise that to the third power, what does the rule say? That's a to the 2 times 3, which is a to the 6th. That's what the rule says. You should get a to the 6th. Let's see if that makes any sense. A to the second. Well, we know that's a times a. We're supposed to cube that. Well, we know that that means a times a A times A times A. 3 of those pairs of A times A. How many A's are there? There are 6. So there are 3 sets of 2, which makes 6. Power rule, you multiply. So if I look back up, product rule, when it's a product of like bases, you add the exponents. When it is powers raised to powers, you multiply. There are 2 little, what are sometimes called corollaries to this power rule, which means they're kind of sub-rules. If you had x to the second, y to the fourth, raised to the 5th power, these are not like bases. They are different factors, but each one of them is affected by the 5 on the outside. So I use the power rule twice. I will get x to the what power? 10. 2 times 5. Y to the 20th. 4 times 5. Okay? If I have a fraction or a quotient, let's suppose I have x to the 4th over z to the 8th raised to the 2nd power. Both the numerator and the denominator are affected by that exponent and the power rule. So I will get x to the what? 8th over z to the 16th. And once again, the clue, the visual clue, is the power outside parentheses. You're going to use the power rule. It means to multiply the exponents. Yes, sir. Yes, sir.
Okay, so pretty much we're distributing that one.
It does feel just like the distributive property. Yes, it is not mathematically called the distributive property, but it sure feels like it.
Would you be able to reduce that?
No. Okay, good question. Could I reduce that? No, because those are exponents. Okay, so we've done the product rule and the power rule. The next rule is the quotient rule. The quotient rule says if you have like bases, let's say I have a to the x over a to the y. I keep the a because they're like bases, and I subtract the exponents. When I multiply, I add exponents. When I divide, I subtract exponents. An example, what if I had 2 to the 5th over 2 to the 3rd? That'll be 2 to the what? 5 minus 3, which is 2. Or I could say that that's equal to, and you can't see it on the screen, 4. All right. Mm-hmm. Yeah, depending on what my math lab says about the form of the answer, if it says to write it in exponential form, you would do this. If it does not say to do it in exponential form, then you'd multiply it out. Okay, now let's see if this makes sense. 2 to the 5th is 2 times 2 times 2 times 2 times 2. 2 to the 3rd is 2 times 2 times 2. Could I do a little reducing? Do you agree that that pair of 2's would go, and another pair of 2's would go, and another pair of 2's would go, and what are you left with? You're left with 2 to the 2nd power, or 4. Two squared. 2 times 2.
Oh, that or looks like an N, so I was like,
Oh, it does. I'm going to erase that and make it better.
my bad.
No, my bad. There we go. Better? Yeah. It did look like an N. You're right. All right. Next rule is the zero exponent rule. And this one says, if you have any base except 0, a is not 0. I have to have that little disclaimer out there. And you raise it to the 0 power, what do you think you'll get? Most people think they'll get 0, but they won't. And not if they want credit. Not if you want it to be right. It is not equal to 0. It's equal to 1. That's not really what your guts tell you to expect. But I'm going to try to convince you that that makes some sense. All right, if I had, this is just a convincing an argument. Let's suppose I have x to the third over x to the third. All right, I want to do this twice. The first time, all I want to do is reduce it. What is any number over itself? Okay, so just by reducing, we would all say that it must equal 1.
So we're not going to just put x, we have to put 1.
We just put 1, yes. But I have something else I want to show you. Let's use the quotient rule. What does the quotient rule say to do with these exponents? Subtract them. So it would be x to the 3 minus 3, which is 0. Now, if this expression is equal to 1, and this expression is equal to x to the 0, then what must be true about these two? They have to be the same. X to the 0 has to equal 1. So I could say, therefore, x to the 0 equals 1. Whoa. X to the 0 equals 1. That was just trying to convince you. You believed it had to equal 1. You believed it had to equal x to the 0. So those two must be the same. And we will do a little bit more with 0 as an exponent in just a few minutes. The last thing, which we will not look at any examples of today, is negative exponents. They are not taught in lesson 5.1, but they are taught in this chapter. And it says if you have a to the negative x power, it has nothing to do with the sign of the answer, nothing whatsoever. What it has to do with is the position of the answer. It is 1 over a, so now it's become a denominator, to the positive x power. Negative exponents say to you, move me. And I'm really not going to go into that with any more depth today, because we're not going to deal with negative exponents in this lesson. I just wanted all the rules on one sheet. So more on those later on. So the rules that we will use today are the product rule. If you multiply like bases, you add the exponents. The power rule, if you take a base to a power and raise it to another power, you multiply exponents. Quotient rule, when you divide, you subtract exponents. 0 exponent rule, any base other than 0 to the 0 power is 1. Pardon? The quotient rule. The quotient rule said that if you divide like bases, you subtract the exponents, the top minus the bottom. All right, the questions. These are the questions from my math lab. Let me make that. I'll rewrite those. All right, the first one. It says to, and I'm going to emphasize instructions, it says to evaluate the expression. So I'm supposed to find a value for this. And I have negative 3 to the 4th power. If you happen to have had Math 301 with me, I know we've had this discussion before. Negative 3 to the 4th power. Do you know what the base is for that exponent? It actually is positive 3. The only way negative 3 could be the base is if it's in parentheses. This actually means negative or opposite of 3 times 3 times 3 times 3. The base is only that number right beside the 4. The negative sign says find the opposite of.
Is that always?
Yes. Uh-huh.
So basically,
If it's not in...
being negative is just irrelevant.
The negative out here is simply going to travel along with the answer, and it in no way impacts what you get over here. So what's going to happen is this negative will travel all the way over here, no matter what, and then I have 3 times 3 is 9, times 3 is 27, times 3 is 81. Can't see that on the
But
screen.
that's positive 81? So it's negative 81.
It is negative 81.
You don't have to count like all.
No. Okay, so now let me show you what many of you are beginning to process in your mind and maybe get confusing. Okay, I want you to contrast with negative 3 in parentheses to the 4th power. This is a different problem. This, the negative 3, is the base because I put it in parentheses. It means negative 3 times negative 3 times negative 3 times negative 3. So in this case, I say, oh, I've got 4 negatives. That's going to give me a positive. It's going to give me a positive 81. So when the base is in parentheses, you might get a positive answer, you might get a negative answer, depending on whether the exponent is even or odd. But when there are no parentheses, you will get this negative to simply travel along and stay with the answer. Does that make some sense? All right, let's look at number 2. The second one says to evaluate this expression, and it has negative 4 in parentheses to the 4th power. Is the negative part of the base? Yes. And this becomes negative 4 times negative 4 times negative 4 times negative 4. I have 4 negatives. So will my product be positive or negative? Positive. And it's 4 times, I'm going to ignore the signs now because you told me it would be positive. 4 times 4 is 16, times 4 is 64, times 4 is 256, and it is positive. Now, I'll do it again. Contrast with, what if I had negative 4 to the 4th and I didn't put it in parentheses? It would be negative. That would just travel along, and it would be negative 256. And you can have your calculator will show you this same thing. Put it in parentheses if you want it to be treated as part of the base. Don't use parentheses if you just mean opposite of.
On the first one, negative is positive,
Mm-hmm.
and then you have a positive and negative, that's a negative.
Uh-huh.
And
And
negative.
yes. Okay, you got it.
Wait, y'all got negative 256
For the second one?
Yes. So, for this second one, for this one down here, without parentheses.
I did them backwards, I'm sorry.
Okay.
Okay, I got it.
All right, let's move on to number 3. It asks me to evaluate the expression, and I have the fraction 1/5 raised to the 4th power. If you want both the numerator and the denominator of a fraction to be affected by the exponent, in other words, to be the base, if you want that to be the base, you have to use parentheses. So that will be 1/5 times 1/5 times 1/5 times 1/5. I have 1 times 1 times 1 times 1, which is 1. Be sure you don't switch and add them. And then 5 times 5 is 25, times 5 is 125, times 5 again, 625. So the exponent affected both the numerator and the denominator. Let's look at number 4. Problem number 4, I have -2 times 8 to the second power. All this problem is really doing is seeing if you remember your order of operations. What would good old Aunt Sally tell you to do first? Exponents before multiplication. 8 to the second power is 64. I have -2 times 64, which is -128. These first 4 problems, I don't think that any of the rules have really applied to these. Any of the rules that I've given you. Let's go on to number 5. Number 5 has -4x squared as an expression, and they ask me to evaluate it when x is -5. What am I going to do? Plug in. And this should feel a little bit like when we did function notation. This is -4. Now, something that's important. When you plug a number in for a variable, it is a good safety mechanism to use parentheses around it, especially if it's negative. Okay, now order of operations. What will I do first? I will I will use the exponent, so that'll be 25. And what's -4 times 25? -100. So the thing to remember from this problem is that when you substitute a value in, make sure you put it in parentheses.
What'd you do, 25?
-5 times -5 because of the squaring. Negative times negative will give me positive. 5 times 5 is 25. Okay, all of those problems ask me to simplify or evaluate. Number 6, use the product rule to simplify the expression. The product rule. Now, when you eventually test on this, I will not say use the blank rule. I will just say use all the rules. And you have to look at it and say which one would be appropriate. So if you look at 9x squared times 3x squared, what's going on? Isn't it multiplication? That should tell you product rule. Now, you can drop off the parentheses. This is 9x squared times 3x squared. And then our very first lesson in this course talked about the commutative property of multiplication, which says you can reorganize the positions. You could keep the 9 out front and the 3, and then put the x squared times the x squared at the back. I just moved them. I used the commutative property. You probably will not write those 2 steps down. In your mind, you'll grab the 9 and multiply it by the 3 because they are both numerical coefficients. And 9 times 3 is 27. You can then grab the x squared times the x squared. Those are like bases. What do you do with their exponents? Add them. So it would be x to the 4th. And that's my answer. So I multiply the numerical coefficients. I multiply the x's, but I do that last part by adding their exponents. So that is product rule. That is the product rule. Okay. Let's look at a few more. Number 7, it says use the product rule to simplify. Write the result using exponents. Okay. I have -5 y to the 4th z to the 6th times 6yz to the third. All right, I'm not going to write out all my little extra steps this time. If I multiply the numerical coefficients, what do I get? Negative 5 times 6. Negative 30. When I multiply y to the fourth times y, I get y to the fifth. And when I multiply the z's, what do I get? Z to the ninth. So you multiply plain old numbers the way you've always multiplied plain old numbers. You multiply like bases by adding their exponents. And did everybody see that this y had an implied exponent of 1?
But we don't evaluate it.
We don't evaluate it because they did not give us a number to plug in for y and a number to plug in for z. Okay? Number 8 says use the power rule and power of a product, which is one of those little corollaries that I mentioned. It's kind of an application of the power rule. All right, I have 4q to the sixth raised to the third power. It's going to be kind of like the distributive property. Everything gets raised to the third power. What is 4 to the third power? Well, I guess maybe we can find that out in just a minute. 4 to the third power, we're going to figure it out. Q to the what? 6 times 3 is 18. That's me using the power rule. I multiplied the exponents. And now, 4 to the third, 4 times 4 is 16, times 4 is 64, q to the 18th. So if I have a numerical coefficient raised to a power, unless it tells me to leave it with exponents, I multiply it out. The last question says to use the power rule and the power of a product or quotient. All right, let's see what in the world that's talking about. I have R over S quantity squared. Yes, I am going to let that exponent affect the numerator and the denominator and get R squared over S squared. So the power rule applies when you have a product, it applies to both of them. When you have a quotient, it applies to both of them. Any questions so far? Okay. Number 10, and I'll have to write this out for y'all to see at the back of the room. It says use the power rule, the power of a product, and the power of a quotient, and I cut off the rest of the instructions. All right, I have negative 7 x to the third, z to the third, over y to the fifth, all raised to the third power. This is really going to let us know if we've got the power rule. It's going to have power of a product and power of a quotient. The 3 is going to affect every one of these factors, top and bottom. And notice that the negative 7 is in the parentheses. So it's going to be negative 7 to the third power. All right, 7 times 7 is 49 times 7. I did it in my last class, so I remember. It is negative 343. It's just because I remember it. X to the what? 3 and 3. Okay, do I add them or do I multiply them in the power rule? I multiply them. 3 times 3. Z to the 9th over y to the 15th. So I raised negative 7 to the third power, and I did it by saying negative 7 times negative 7 is 49 times negative 7 is negative 343. I raised x to the third power by multiplying the exponents. Z to the third power, multiply. Y to the fifth to the third power, multiply. So I've used my power rule. Yes?
I hate to make it
Okay.
okay. This R squared, R over 7 squared, over S squared.
Yes.
All you do is, capitalize. Oh, it was capitalized anyway. You capitalize.
I just capitalized them because sometimes you can't tell my R's from my S's when they're lowercase, and especially if I start doing cursive weird things. No, it's no big deal. I didn't say I did that. I just capitalized them because I thought it would be clear. So much for what I thought. All right, number 11. Change up on the instructions. It says use the quotient rule. I have x to the 6th over x. What's the exponent on this denominator? A 1. So what does the quotient rule say to do? Subtract. So I'm going to have x to the 6 minus 1. You don't have to write that step down. It's x to the 5th. What you're going to have to do is identify for yourself what's going on. Division. Quotient. Quotient rule says keep the base, subtract the exponents. Yes, anytime you divide, you have to subtract the exponents. The rules are on your blue sheet. Yes. All right, the last few problems. Problem number 12 says use the quotient rule. I have p to the 9th, q to the 4th over p to the 3rd, q to the 2nd. All right, what do I do when I have a quotient? Subtract. So I get p to the 9 minus 3 is 6. Q to the 4 minus 2 is 2. Quotient rule, subtract exponents. All right, the last ones I hope you will find to be very, very easy. Number 13, it says simplify the expression. It doesn't reference a rule. I have 10 to the 0 power. That is equal to 1. Number 14, I have 3x in parentheses to the 0 power. That's equal to 1. Any base to the 0 power is 1, except for 0. I'm sorry. If you had 0 to the 0 power, it's considered undefined. We won't throw that at you, but it has no value. Or it has an undefined value, I should say it that way. All right, number 15. 10 to the 0 plus y to the 0. Pardon? Okay, it is 1 plus 1, which is 2. I thought I heard somebody say 7, and I was getting curious about...
So you don't worry, you don't pay attention to the number because it's in the parentheses, right? Like the one before that.
The one before that, no matter what that is or how complicated it is, if it's raised to the 0 power, it's equal to 1. Okay? Yes, sir? No, the zeros didn't cancel out. It's just that any base to the 0 power is equal to 1. If I went all the way back to my rules, here it is. Okay, I'm going to go ahead and